Today we are going to take a look at one of the most common type of stormwater control structures, the standard stormwater detention pond, also known as a basin. This video will demonstrate how to evaluate and prioritize if a stormwater detention pond needs to be retrofitted, things to consider in design, what to expect during construction, future maintenance needs, and lessons learned from past projects to improve water quality. But let's start at the beginning. What is stormwater runoff? Stormwater runoff is precipitation in the form of rain and snowmelt that flows across the land. Stormwater may soak into the soil, discharge directly into streams, water bodies, or storm drains, or evaporate back into the atmosphere. In the natural environment, most precipitation permeates into the ground to replenish the natural water table, or is absorbed by trees and plants. This results in a stable stream flow and good water quality.
And stormwater is a really, really good thing. People have to understand that, because without water, we have nothing. It's the single most important resource we have.
If we think about stormwater runoff has three components. It has the component of rate. Rate is measured usually in terms of cubic feet per second. The second component of stormwater runoff would be velocity. And then you have, of course, the quantity of water.
Some people just want to get stormwater off of their property or off of their roadways. That's fine, but you can't just dump it into a stream and forget about it. So we have to understand now that stormwater, when it falls from the sky, something's going to happen to it. It's either going to run off, it's going to soak in, it's going to evaporate. Something's going to happen to it, and we got to make sure what happens to it is to our benefit.
So you're probably thinking, why is stormwater runoff a problem? Stormwater running over roofs, driveways, roads, and lawns will pick up pollutants such as oil, fertilizers, pesticides, dirt and sediment, trash, and animal waste. These pollutants hitch a ride with the stormwater and flow untreated into our local streams and drinking water sources. When these pollutants enter drinking water supplies, it is often very expensive to treat and remove. Did you know that sediment is the #1 non-point source water pollutant by volume in the Commonwealth of Pennsylvania in the United States? Soil washing off of active construction sites, farms, logging roads, and other exposed areas often ends up in streams, ponds, lakes, and rivers, where it can cause a variety of problems, from smothering aquatic life to increasing the chances of flooding.
Most stormwater basins have been put in, at least in this area, in Westmoreland County, related to development. So they're really there to hold the water back, to hold the increased stormwater flows back from that development. That's their job. What happens outside of that development, that's beyond the scope of what the pond was designed for. So there was a lot of development that was done before stormwater was an issue. And so we still have flooding issues. We still have a lot of areas that have a lot of impervious rooftops and driveways and streets and parking lots that are uncontrolled.
If you have a rainstorm, the runoff in an urban area starts almost instantly. The water hits the roof of the house. It runs down from the roof into the roof gutters. It runs down the roof gutters into the downspouts and down onto the driveway of the house or onto the sidewalk. It runs on the sidewalk or the driveway. It runs into the street, runs down the street into the storm drain, into the drain it goes, and then down into the stream below, without ever having had a chance to soak into the ground or infiltrate. This basin was built to control stormwater runoff from a parking lot and the roof of a building in an industrial park. And when it was designed primarily to be a dry detention basin. That is, after the rainstorm had passed, the water would drain out and the pond would be grass. Now you'd say, why would you retrofit the pond to hold water? But in fact, you want the pond to hold water for several reasons. First of all, when the pond holds water like this, any pollutants that are in the stormwater that runs into the pond are trapped and are held in this permanent pool here and given time to settle out. So this is a way to settle pollutants out of water. Second of all, this is a way to attract wildlife, and this pond is actually quite a valuable place for wildlife. You'll notice there are insects, there are ducks, there are fish, there are amphibious creatures here, and if you look at the ground, you'll see all kinds of footprints of animals that have come to this detention pond to get a drink of water. So in an urbanized area, a detention pond can be a little oasis in a sense, providing valuable wildlife habitat.
Although stormwater basins are the most common stormwater control, we have found that many are often malfunctioning. Let's take a look at some basins to determine why they are not functioning to their full potential.
Before the water ever gets to a stormwater basin, before it ever gets to a stream, we want to send it through some kind of stormwater BMP, best management practice. We have rain gardens to collect water off rooftops. We have pervious pavement so that whenever the rainfall hits the pavement, it doesn't just run off into the stream. It actually goes through the pavement, maybe into some kind of a sump or rock sump that holds water or some other treatment device. So it's a lot longer time before that water ever gets to the stream. And when it gets there, it's not getting there as fast and it's getting there cleaner.
One way we're able to tell if these basins need retrofitted or not is whether they hold water or not. And by looking at this flow path that I have in front of me from the pipe that's coming from the road, it goes directly to the outlet riser of the basin. We have a direct flow path, which is never good, but in that flow path is very little sediment, indicating this thing does not fill up with water and drop sediment out entirely throughout the basin. It's a direct flow path with very little sediment, so this thing, if it holds any water, holds very little, and we're able to tell that because this flow path exists.
But you knew that if it's not holding water, it's not doing its job, it's adding to the problems downstream. And one basin alone probably doesn't make a big deal, but if you've got 20 or 30 or 100 basins that aren't performing, then it's going to be a significant issue.
With this basin, it's very typical. It's a dry basin. Although you see cattails in it, it never retains water. It just has a moist bottom to it. That's why the cattails are there. So in this retrofit, we actually have the opportunity to make it a permanent pool of water. The residents here actually wanted to see water in this pond, so the retrofit is going to be a permanent pool of 2 to 3 foot of water, and that actually helps improve water quality because we're holding the water here permanently, a permanent pool for all the fine material to drop out, and it's also going to be good for wildlife. So this is a retrofit that's actually going to have a permanent pool of water in it. Also, with the fence here, we don't usually recommend fences on basins. A lot of municipalities are concerned about liability and the danger that it imposes, but it also prevents maintenance. With this one, you can see it being grown up. It doesn't look as appealing, and it also lends to trees being grown on the embankment, which tends to loosen the soil and not make it a sound. So if possible, we'd like to see this fence removed so it can be maintained, so it's more aesthetically pleasing in the neighborhood, but also so trees don't grow in the embankment and compromise it. So whenever we see these metal risers attached to plastic outlet barrels, it's never a good thing, because metal was never meant to be attached to plastic. It's always a failure point. And the fact that I can stick my hand in here indicates that water can never actually fill up into this thing and go into the top of the riser like it was intended to. It actually finds its way between the metal and the plastic. So that way, this basin can never truly hold as much water as it was intended to.
A lot of these basins have a lot of debris in them that haven't been cleaned out, a lot of vegetation that needs cleaned out. Again, that's not a very expensive item. So, and for $10,000 or $20,000, you can do something that initial construction might cost $100,000 today. So, it's definitely worth it. Bang for your buck.
Some people will call a detention pond a retention pond, and there's a slight difference there. Usually, from a word standpoint, detention ponds hold water for a short period of time, and a retention pond is designed to hold the water for a much longer period of time. Usually, we would think that a detention pond would hold the water for maybe 5 hours or 10 hours or something like that before the peak flow can be reduced. But a retention pond might hold the water in itself for several days. And the longer you hold the water up to a point, the better improvement of water quality you have, because the more pollutants will be removed from the water. On the other hand, you don't want to hold the water so long that the pond is not empty and ready for the next storm. So usually we would say that a retention pond should drain back down within 72 hours of filling up. We know that the smaller storms, the storms of less than 1 inch of water, are most frequent, most common, and they are most important to capture and treat and manage. Those little storms, the half-inch storm that you get, that carries with it as much pollutants and chemicals and trash and debris as a 2-inch storm. If you look at the picture, you'll see here an illustration of a pond that has a wet pool and a sediment forebay. That makes the detention basin more efficient because it captures a great deal of pollutants in one small area, and then the water is treated again in the rest of the basin. Detention basins often have a dam. Now, the dam is an earth embankment, usually constructed by workers with bulldozers, and they will clear the land, and then they start putting layer upon layer of earth in, compacted with machinery. So the dam is what holds the water back in a detention pond. Besides the dam, you have an emergency overflow. The emergency overflow is designed for those very rare occasions when we might have 6 inches or 7 inches of rain in a 24-hour period. That's a very rare event, but that can happen. And so the emergency spillway is designed to handle that super heavy rainstorm that will completely fill the retention pond to the brim. The detention basin has a riser, which is a vertical structure. The riser will control the outlet of the water from the detention basin. The riser is a metal or concrete or plastic stand pipe. It's a vertical pipe or a vertical box in the detention pond, and that may have holes in it, and so the water rises up on this structure and flows out through the small holes and then leaves the detention pond. That riser is designed to provide the rate control for stormwater running out of the detention pond. The riser is connected to a barrel. The barrel is what runs through the dam usually, and that's how water gets out of the detention basin. That barrel is designed to safely pass water through the dam so that the dam is not eroded. Now, where the detention pond pipe outlets is called the outfall. That's usually into a stream or a body of water. But at that outfall, you want to prevent erosion. So we often will have someone will put rock riprap being large, blocky kind of boulders of durable rock to dissipate the energy of the water as it's coming out of that pipe, so that it does not scour or cause a hole in the stream down below. Some of the plants you'll see in a detention pond might be cattails. You'll see sometimes water lilies or other floating water plants. And you see the rushes there, the tall circular in section plants. You might see sedges, which are triangular in cross-section. When you roll them between your fingers, you'll feel the triangularness of the stem. So those wetland plants then are growing in this detention pond. Those plants provide food for animals and for fish, and they also provide removal of nutrients from the water. These plants will lift and remove certain nutrients from the water, cleaning the water as the time goes along. Plus, of course, the plants will remove water itself from the detention basin through the process of evapotranspiration. So they will reduce the amount of water that runs downstream, they'll increase the amount of water that's lifted into the sky, and that helps reduce flooding and control runoff downstream.
Well, MS4, Municipal Separate Storm Sewer System, that's a program that was put in place by the EPA. It's nationwide. In Pennsylvania, the Department of Environmental Protection kind of administers that program. And all municipalities that have urbanized areas have some kind of MS4 permit from DEP. And the goal of that permit is to ensure that the stormwater that's running off from these urbanized areas is controlled. When we looked at stormwater 40 years ago, all we were really looking at was the volume of runoff. So now we have three issues that we really deal with. We want to still control the rate. It's very important. We want to control the volume, and we definitely want to control the water quality, make it better water that's running off. So at MS4, the goal of MS4 is to really achieve all three of those. Let's control the rate, let's control the volume, let's get the water quality better. So through this program, municipalities are required to have pollution reduction plans now, which means they're looking at these areas that were developed without stormwater controls and they're going to have to figure out how they can do some kind of stormwater retrofit here. So through the MS4 program, by doing the retrofits, you're getting your credits, you're helping your pollution reduction plan, you're meeting all the other requirements of the MS4 program. I've noticed that one of the things that is imperative with everything we do is maintenance. I think that's a lot of things people don't think about as maintenance. You usually don't find funding for maintenance. You find funding to build new things. People are always excited to build new things, but then comes the task of maintaining them. And that goes for every piece of infrastructure: water lines, sewer lines, roads, bridges, and stormwater basins. The public works crews around here, they plow snow in the wintertime, they pave roads in the summertime, and they cut grass. And stormwater maintenance just has not been high on their list. Through the MS4 program, though, they're going to basically be required, because that program requires you to document everything you do. And so you're going to have to document how you're maintaining all these stormwater facilities.
In Part 1, we assess stormwater basins to determine if they need retrofitting. Stay tuned for Part 2, where we will discuss construction.